Here we have a partially disassembled Villiers 9E engine that has been removed from a Penguin. I received this engine disassembled almost to this point. I think I removed the piston from the connecting rod here. Other than that, this engine is pretty much as I received it. It has a few issues, and we're just going to try to confirm the extent of the issues to see what's needed to put this engine back together. Okay, when this engine was taken apart, it was discovered, of course, that it was seized. It was difficult to take apart. Piston's been burned here. The rings are stuck in their grooves. Piston's got a few scuffs on it. That side scuff is the worst. It's got corrosion on it, which would have come off of the cylinder, but it's broken. So this piston is not reusable. That is the front of the piston. It's marked there. It's broken. That would not affect exhaust or intake timing, but it's broken. It'll affect the weight of it. It's cracked. It can break some more. So this engine is going to need a piston. Now, the cylinder, of course, is the other half of the equation here, and it doesn't look great. There's some, actually, that looks like corrosion on the cylinder there. Oh yeah, that's coming off. So that's on the cylinder, so that's not bad. It's coming off. There is some scratching in the cylinder in here. It may come out with a simple hone, so we may be able to reuse that without it being machined. Now the cylinder is cast iron. Looks like there was a mouse nest in this engine when it came apart. But I think that cylinder, well, is definitely usable. There's no broken fins on it. The exhaust nut did come off of it, by the way. And the carburetor's been, intake manifold and carburetor been removed, and those spacer gaskets have been left there. So we'll have to get this examined by a machine shop to see if it's something that just needs a hone passed through it, or if it needs to be machined. Okay, now on the cylinder, of course, would have been mounted carburetor. Now the carburetor is here. Of course, when it was removed from the Penguin, the top ring and disc and throttle and choke slides and cables, etc., would have all been removed, probably left in the machine. So here we have a carburetor that looks a bit dirty. The air filter's on there. We can just, it's lost its emblem, but the emblem is actually here. But this can be removed just for sake of handling. The air filter is removed. The clips are on here and they're held on with the proper screws, which isn't always the case. Now we may be able to see there is quite a bit of stuff, to put it politely, in the carburetor bore there. It's dirty, but it doesn't look too bad. There's a little bit of corrosion here. The mouse nest may have actually been, this is partially covered by the cooling shroud, so the mouse nest may have been in around that and caused some corrosion. So anyway, we'll take the bowl nut off of the float bowl. Take the float bowl off. The bowl is dirty, but it doesn't look corroded. Oh, it smells of old fuel. And the float, I'm just going to get some to wipe it here. The float is a brass float, and it's got gunk on it here. It's partially crushed. Oh, this one was on right side up. I just had one apart here that was on right side down. This is hollow brass float. Looks like water's gotten in the float bowl. Water sits underneath the fuel, water freezes, looks like it crushed the float. So this will need a float, but looking in between the float and the carburetor body looks to be in pretty good shape. I'm just going to remove the main jet here. This is the main jet which holds the float on. There's a screwdriver that fits it well, and so we don't strip it. It's brass. So we'll just take this main jet out carefully, not dropping it. We'll take the float off. There's the float. Now we have to be careful that we have the float off. This is the banjo fitting where the fuel, this is the fuel fitting, the fuel line, banjo bolt, banjo fitting. Fuel comes in here to this inlet needle. This inlet needle is not held in by anything once the float's removed, so we'll take that off. The good news is this carburetor body looks to be in good shape. It's not corroded in here. It's not corroded in here. We saw one previously that was corroded right through here. So this one, other than a little cosmetic corrosion out here, we'll check and make sure that hasn't gone right through it. But anyway, that carburetor appears to be rebuildable. We can get a new float for it. We can get gaskets for the float here, float bowl. Let's put this all back together. There's a fiber washer on the bowl nut that will be replaced. And the banjo fitting, here's the bolt, the banjo fitting, because it looks like a banjo, it's round, the neck on it. Banjo bolt, fiber washer, banjo fitting, fiber washer, and in here should be a filter screen. I'll just grab my wrench. British standard wrench. That's a 5/16 wrench, believe it or not. British standard. I'll just take this bolt out. Just make sure the filter screen is there. If not, we can put it on the list of things we'll need to get. Put this back together. So yeah, there's the filter screen. So there's the banjo fitting, looking like a banjo. One fiber washer. And there's the cylindrical screen, which will need to be cleaned, but anyway, it's there. There's the passage. The fuel comes in the banjo fitting, so it comes around the outside of the fitting here, in through this, through the screen, in through this port, and out into the carburetor. So we're just going to put this all back together, back on the carburetor for now. So that will need to be well cleaned. We'll just confirm that the corrosion on the in this location isn't right through the body. It's fairly thick there, so I'm fairly confident it's okay. So we'll just set that aside. And one of the other issues this engine had, I believe the rotor was stuck. This is this Dyna-start rotor. This goes on the other side of the engine. Can't see it right now, or where it goes right now. This is the Dyna-start rotor. It's very heavy. It's a steel outer piece. It's lined with copper windings here. There are steel pole pieces here, and there can't see it very well because it's greasy or dirty. Anyway, it needs to be cleaned up, and the condition of these faces here, down here, checked, because that is where the brushes for the starter generator contact. Now this may be okay, just needs to be degreased and then the rust removed. It doesn't appear to have any damage. I don't see any places where the copper windings are cut or crushed or anything, so that may be okay. But now we'll just have a look at the engine. Oh, look at that. In my rush here, I forgot to put the main jet back in the carburetor. Better do that. So we'll just put that back in. Just going to thread it in just enough that it doesn't fall out. Roll back on. There's a good reason why you should take your time when you're doing this and keep track of everything. Okay, so there's the carburetor back together. Now, a few tools out of the way here. Now, if you haven't seen any of the previous videos, I made a stand out of some angle iron, just a flat base here with a couple uprights to hold the engine so it's not rolling around while I'm trying to work on it. Here's the wiring for the Dyna-start. Tuck it out of the way, and I'll just turn this around. Try not to drop it. There, so I got that in frame. Yeah, so here's the stator for the Dyna-start. Again, it's steel pole pieces. And the rotor function as an electric motor to start the engine, and then act as a generator to charge the battery and provide power for the lights and ignition when the engine's running. So anyway, pole pieces, copper windings, which have insulation on them and appear to be dirty but otherwise in okay shape. These are rusty. There isn't a lot of clearance between these pole pieces and the pole pieces on the rotor, so these will need to be cleaned and should be coated with something, maybe just a thin coat of paint to try to slow corrosion down in the future. And here there are 4 brushes, or the remnants of 4 brushes, which will have to be replaced. They're broken and looks like there's springs behind them, which if this is corroded, the chances are the springs have got corroded, weak, and possibly broken, so this will need a new set of brushes. Again, I don't see any obvious damage on the stator. The insulating tape is in place. Nothing appears to have suffered an impact. Now on this side of the engine we have the clutch lever, which is very loose. I'm not sure if this has been backed off, but anyway, the cover has been off the transmission. We're going to actually at some point separate the transmission from the engine to see what it looks like inside. There's a contact missing here and what looks like a gear normally with a pin to contact the contact that's missing here for the neutral indicator light. Gear shift is off, of course. But anyway, that's this side of the engine. The stator appears to be weathered, we'll say, but I think it's going to be usable with a new set of brushes. We've had the piston's been removed from the connecting rod. The connecting rod has a little bit of side play. We'll have to check the maintenance manual and see what's allowed there. I've just put some elastic bands on there so the connecting rod can't hit the crankshaft and cause any damage. So we'll just turn this back around. Again, I mentioned it before. When this was taken apart, the wires have all been nicely marked. They're still almost all in the grommet where they attach to the control box. These wires are actually all marked. It says B2, B1, M, etc. Sorry, it doesn't say etc. on it. That says, I think, HB possibly, DF, HE, and so on. Anyway, those terminals are all marked on the wires, and the terminal block on the engine, on the control box is marked. Here we can see the wire for the neutral indicator that's here loose. The points wires are here. Of course, one for forward, one for reverse. They would go to the cover that's missing, and there's the ground wire for the engine that would be under the transmission stud. So, okay, I'm gonna dig into this a little bit. Just put something here where I can see small parts, like that carburetor jet that I almost forgot. Of course, now the engine is actually engine, transmission, an electric starter, generator all in one unit. The starter generators have been removed. Part of the engine has been removed, the cylinder head, cylinder, and piston. And the carburetor, of course, attaches to the cylinder. But the engine is from here forward. Transmission is here. The fan for cooling is here. It's on the crankshaft. The engine is connected to the transmission with a chain. The clutch assembly is here. The clutch lever is over here. But there's a push rod that comes through to actuate the clutch. So we're going to take this chain case, the fan housing and chain case off, take the clutch and primary chain off, so we can get the engine separated from the transmission and listen and see if that noise we hear is the crankshaft bearings. I think it is. Anyway, while we're here, we can see this fan. Maybe we can't see it in this light, but anyway, this fan has a broken blade right there. Sometimes when working on this engine, it's very tempting to stick something down in here to try to get the engine to turn over. This fan is cast aluminum and breaks very easily. Fortunately, we could replace the fan. We could also attempt to balance it in another way, but anyway, we'll see what happens as we go. Now, this fan has been off. I can tell because these nuts aren't in place. It should have two nuts on it. They're jammed together, so this can't loosen. It's right-hand thread. The engine turns both directions, so I guess they want to make sure that the nuts can't come loose. So there's two nuts and a lock washer. And the fan should wiggle off the crankshaft. Now, the fan is cast aluminum on a steel hub that's held with screws, but we don't need to separate the fan from the housing, from the hub. Here's the back of the fan. It's quite dirty. There's actually supposed to be a felt covering on it here. I'm not sure what that felt covering is used for, but anyway, it's missing. And there's the hub. We'll just set all of this aside. Start putting some of these small pieces into little zipper bags so that they can't go too far astray. Now, the fan housing and outer chain case. Here we have a plug that can be removed to top the oil up. I'm just turning it over to see if there's any oil on the clutch. The clutch is actually right there. I don't see any oil on the clutch. The chain and clutch, there's an oil bath in this housing. It just means there's of course we put oil through this in this plug. It says SAE 20 or 30, either one's probably fine. This plug we can see here is a level indicator plug. There's actually a plug under the bottom here to drain it. Back right there, we'll see that later, and a plug further up, which may be either a drain plug or another level indicator plug. But anyway, we put oil in this, pull this plug out. When the oil runs out, we know we have enough oil in the chain case. Okay, so we're going to take the outer chain case off. There isn't a lot holding it on. There's simply one nut on a stud here. So we'll try a wrench. Yeah, this has been off, so the nut is loose on the stud. So I'm just going to take this nut off. We can't quite see it in the angle we're at here. You can see the case is already trying to fall off. And this has been apart. It was partially disassemble. Now the stud has come out with the nut. We want to take that nut off and put the stud in. I'm going to put it back together. So there's the outer chain case off. Now on the outer chain case, now that we have it off, we can see there's an adapter here with a seal to try to keep any oil that would have been in this chain case from leaking out. Set that aside. And now we can see we have, this is the primary chain, runs between the crankshaft and the clutch. We have a Woodruff key here that we're going to have to remove. So to come out, we have to remove the Woodruff key to get this spacer off. We'll try carefully a pair of locking pliers. There we go. Trying not to damage anything. Okay, so there's the Woodruff key out. Again, it's sometimes called a half moon key. Put that in a bag of loose pieces. So with the Woodruff key out, the spacer should come off. We can see here that the primary chain has a bit of play in it. We'll check the manual to see what the specification is. The primary chain is adjusted with gaskets added or removed in this joint between the transmission here and the engine here. So that gap, we would add gaskets to tighten that, which means we'd have to take it all apart, separate the engine from the transmission, or transmission from the engine, add or remove gaskets, put it all back together, check the tension, and then adjust as required. The manual says 4 gaskets are the maximum permitted. If 4 gaskets are in there and the chain is still too loose, the chain is worn out. Okay, so put these pliers away. So to remove the clutch, this is the clutch lever, and as we can see, I push the lever which the cable's normally attached to, and the clutch is moving. So we're going to remove, excuse me, this is actually an adjuster which adjusts the length of the push rod that goes through the center of the input-output shaft that the clutch lever works against. So we're just going to remove that. So we're going to take our special tool here. This is a nut. Of course, it's got nothing on it to grip it, although one I worked on previously had like pipe wrench marks on it. But anyway, this is the proper tool to remove this nut. It's got 2 pins on it that engage in the pinholes here, and it's got a hex on it that we can put a wrench on. So we put that on there. We put this bolt in place, which goes in where the adjusting screw was. We get a wrench that fits here and there. Looks like someone has had this off before. That was way too easy to remove. I'm going to take the special tool back off of it here. That tool is readily available. So, I'm going to put a magnetic tray under here. I'm not going to see some small parts yet, but anyway, there's the nut. There's a spacer here. This actually looks like a piston ring. There's a spacer there that we'll have to go back on. Here we can just see the end of, there's the push rod. So we'll take that out of the way. That's actually part of the push rod. There's more than one piece to it. So we can see that push rod wouldn't reach all the way across, so there's more than one of those in there. We'll have to watch that when we are working at this. Now, the next thing we want to do is take this nut off. That nut is even though this engine is made with British standard fasteners, that nut can be removed with a 13/16 socket. And I'm looking for a strap wrench. Now the factory tool for this is they call it a comb to jam the two sprockets together. So we can do this. But I have a strap wrench. I'm going to see if that'll work. Just a strap wrench, commonly used for oil filters. See if that will give us enough grip. And it's not. So I'm going to resort to air. Shouldn't normally use a spark plug socket on an impact wrench, but I'm not installing or removing spark plugs with it, so I just want to loosen this. That has loosened it. So we'll go back to the, there we go, see? So we'll remove that a little bit. I've kind of jumped ahead of myself here. Before we get that off, that removes the nut that removes this washer that holds the springs. There's a series of springs here which provide the tension to hold these clutch discs together. The clutch discs are actually falling out here. That's what reminded me I was ahead of myself. So there are a series of discs here. Some of them are locked to the hub of the clutch, and some of them are locked to the basket of the clutch. And as the spring tension, the springs here, held by the nut holds pressure on the plates. The plates are squeezed together with enough friction that the basket and the hub turn as one. When you squeeze the clutch, the push rod that we've removed pulls out on this, which releases the tension like what we have now, so that if these discs weren't stuck together, I'd be able to turn this hub and hold the basket. So anyway, there should be an outer disc. Oh, here. Now here we have the plates with the friction material on them. This is a steel plate with a friction material which may possibly be cork. It's lined on both sides, but anyway, we'll take those out. So set them aside. So now we can see the hub with the surfaces that the discs lock into. And now, if I hold the basket, we can turn the clutch input shaft, and the transmission isn't turning over. So it must be a neutral. Actually, the clutch, the transmission other cover is loose, so we're going to have to look into this transmission and see what's needed in there. Anyway, we're going to continue to take this nut off. Just still, the springs are holding tension against the washer, so that makes the nut won't come out by finger tight yet. There we go. So the nut is fairly long. So there's the nut. There's the washer that hold the springs in. There's 2, 4, 6, 8, 9 springs. 1, 2, 3, 4, 9 springs, which we'll leave in the hub, and we'll just take the hub off. And if we turn the hub around, there's an inner hub and an outer hub. The inner hub is held tightly and the outer hub can move a little bit. Now there's This hub only goes on one way. There's a lip here, so the clutch discs sit on that. We can't put this on backwards because, well, then the nut wouldn't go on. But anyway, we have to put this on before we put the clutch discs back on. Anyway, I'm just going to set the washer back on that. Set the nut on that. The nut actually threads on this. And our basket is no longer held on there by much, but we don't want to just pull it off. There's a surprise in behind it for us. Actually, a surprise if you haven't taken one of these apart before, or don't have a manual to show you what's hiding underneath this plate. This plate isn't stock, it's keyed to the transmission input shaft, so just gently work it off the shaft here. See, it's loose, it's just a good fit, sliding fit on the splines here, the large splines. So we'll just take that plate off of there. So this is the back of the clutch plate assemblies. Now it's come off with it, but this right here is a, I'm not sure it's brass or copper disc that goes on the back of that. So this is dished on one side one way and raised here for the friction portion of the plates. So that will just set aside, and in here, right in around here, are a series of rollers. There should be 24 rollers there. That's the little surprise if you don't know they're there. And pull the clutch apart, they can come out and go who knows where. So we'll just take those out carefully. Take them off the top, because once we take half of them out, and there goes a roller. Look at that, even being careful. One is leapt out into the magnetic dish. So there's 3. So these rollers are what the basket would rotate on when the engine is in gear and the clutch is disengaged, so the basket is turning but the input shaft of the transmission isn't turning. Again, we don't want to lose these. I've seen lots of these for sale, but why won't we just keep these and reuse them? Those are not all corroded and pitted, which they usually aren't. Should be fine. And now we're getting to the halfway point here. I take this one out, wiggle the basket a little bit, try not to drop that. Lift the basket, take one out. And there, the basket is very loose now. The rollers are going to be very easy to convince to come out. Some of them will leap out when this one beside it comes out. A little bit of oil on them sticks them together. Anyway, we'll take those out. Magnetic tray caught that one. Another one. It's stuck on the magnet on the outside of the tray. It's a good idea if something appears to vanish to find it before you continue. I'm sticking my head in the camera here. So there are all the rollers. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 24 rollers are there. So now the basket is loose. Actually, the old gasket's loose here. We'll take that off. So I'm just going to take the chain off of the basket. Take the basket part way out and move it ahead so there's enough slack on the chain. Take the chain off. So there's the basket. Back of the basket we can see the sprocket's a separate piece from the actual basket, and it's riveted on. The sprocket, the teeth and the sprocket are in pretty good shape. Usually when the teeth wear, they get right to a sharp point, but there's still a bit of a flat there, so of course replacing this sprocket would at this point probably require a basket, and the basket's dirty, but otherwise it's okay. Just for the sake of keeping stuff together, I'll set that all together later. I'll just take the primary chain off. Now, the chain, one way to test a chain, just get a better angle here, is to see how it sags. You hold it at the ends. It doesn't sag a lot, so that chain is probably okay. Actually, I'll just take a second here and put this stuff all together. So I'm just going to put the discs all back in the clutch, set the clutch back together so that it's all in one place. These pieces are pretty big, so it'll be hard to lose them, but I've got something not right here. No. Oh, look at that. Hiding stuff on myself. Okay, so the hub is there. We can see the marks from the friction disc, from the friction material, so that one goes in. Then a solid one. Then there's one friction material and a solid one stuck together. Another pair stuck together. And that goes in next because we can see the marks from the friction material, and then that's the top ring. Then we'll put the the spacer back on. We'll set the nut on. And the nut with the adjuster, the screw, the adjuster screw. You can see the pad on it here for contacting the push rod. We'll just put that back in. So that's all in one spot. And then we'll take, so we're left with the crankshaft sprocket, which is a little bit stuck to the seal, but it came off. It's in pretty good condition still. The edges of the teeth aren't all sharp. And normally speaking, if you replace a chain, it's a good idea to replace the sprockets. So hopefully, because it's an assembly, it all works as a unit, you wouldn't normally replace a sprocket or a chain. They all have to work together, so replacing one and not all three saves you a little bit of money and a little bit of time, but it's going to come back and need to be repaired again because the worn out chain is going to wear out the new sprocket, or vice versa. So we've got the sprocket off the engine crankshaft, which will let us hear the crankshaft bearings better, and there's a Woodruff key in there which seems happy to stay there at the moment. We'll just make sure that it stays there. And there's a loose piece here. This is a drive washer, a hub that we can take off of this is the input shaft of the transmission. We'll take that off. So we'll just rotate this. I don't know if you can hear that, but that sounds like noisy crankshaft bearings. Now, ooh, I'm not sure if that's bearings on the outside of the crankshaft, like there's a set of bearings on each end of the crankshaft, and there's a bearing, I believe there's a roller bearing in the connecting rod, but there actually is a little bit of up and down play in that. Not so much in the other side. But I would say those bearings are rough. That's why they're making that noise. So I think this engine's going to need crankshaft bearings. Not good news, but anyway. So that'll mean this outer chain case is going to have to come off. Inner chain case, and we might as well do that right now. It's very simple to do. Of course, this is the engine crankshaft. This is the transmission input shaft. This is a crankshaft seal here that will have to be replaced. This inner chain case seal will probably replace too. There's one nut on a stud here. Get that off. You can see the cover loose already. Just take the nut and washer off. Pull this off. There's the seal there. Does it look like it's split? No, but it feels very hard. So that would be a good thing to change. Just put that nut on that stud so it doesn't go missing. And here we can see the seam between the engine and transmission. We can see one of the studs here, two more of the studs here. There's another one, the nut is accessible underneath here. If we took those 4 nuts off and the engine wasn't on this stand, we could simply separate the engine from the transmission. The gaskets, the front of the transmission is actually open. We can simply look in the transmission and see how things look. So what I'm going to do is I'm going to do a little cleanup here, put some of these loose pieces in bags, set stuff out of the way. I'm going to take the engine off the stand. I'm going to take these nuts off, this nut off, the nut on the other side off, and separate the transmission from the engine. And actually, just before I do that, I'll get everything ready so it's ready to separate, and I'll continue on from there. I'll be right back. Okay, so we are back, and what I've done is I've removed the engine and transmission from the motor mount, from the work stand, which looks like the motor mount in the Penguin. And I've removed 3 nuts here, 1, 2, 3, and a nut here. That holds the transmission assembly to the engine. And what I did, while nobody was looking, was I gently pried here. This side was loose. And then I took a soft-faced hammer and gently tapped on here until this started to come apart. Now, we'll see if it'll come the rest of the way apart. Look at that. Falling apart here. Okay, so now we'll slide the transmission off of the engine, off the base of the engine. Just try not to drop anything here. Okay, so there is the engine. Just set that on its face for now. So here are the 3 studs that the transmission mounts to. 3 of the studs. There's dowel pins here to locate it. So the transmission is exactly in the right spot, so the chain lines up. And here are the gaskets, which are used to set the tension on the, or set the amount of slack, I guess, in the chain. You don't want tension on it. So anyway, these are the gaskets that would be removed or added to add more or less slack in the chain. So there are the gaskets. I'm just going to leave them on for now. Set that there, make sure it's not going to roll off the work table. So there's the transmission assembly. And there we can see, not very well, but we can see most of the inside of the transmission. So the gear shift, here, let me move this right out of the way. Set it carefully out of the way. Okay, so here we see this is where the gear shift goes on. The gear shift is, they call this the later design, and it's a ratchet style design. What happens is the gear shift lever goes on here, connects with a rod to your gear shift handle. The handle should always return to the same position no matter what gear you're in. You simply pull it up for first gear, release it, the handle returns to its home position. Oh my god, engine's cleaner, my hands are dirty. So the gear shifter should return to the same position every time. There's a U-shaped spring and then like an A-shaped spring and a set of pawls in there that make sure the ratchet works and the handle returns to the same position every time. So that's the gear shift. There's a shaft through there with a sector on it, a gear that only has it's not a complete round gear, and it works with a gear on this shaft. This shaft, as it's turned, it has pins on it which make these. This is the gear shift fork. It's in a groove on this gear. So what happens is, as this is turned, this moves back and forth and it pulls this gear over or back depending on where it should be. It's quite interesting if you can see this all work, because of course there's a neutral position, which this is in now. So this is the input shaft, and it actually goes through the center of the output shaft, which is here. So there's the input shaft turning, not connected to the output shaft. I can hold one or turn the other. So this would be the gear, of course, you'd use when the engine's sitting idling and you're not moving. When you pull up on the lever, it moves things around, so it engages one of these gears with a set of gears on a shaft. This plug indicates another shaft here that goes across there with a set of gears. So this gear would engage with would engage with one gear on the shaft, this other shaft, and then would possibly move another gear as well, so that this input shaft is geared to this output shaft at 1 ratio. Then say for example, I don't know the gear ratios off the top of my head, but say first gear, you want this to turn, the input shaft to turn 4 times for every 1 time the output shaft turns. So then you select second gear, and that changes the ratios, so the input shaft may turn 3 times for every time this turns. So this is turning the output shaft faster in relation to the input shaft. Then third gear would be, say, 2 turns of the input shaft to 1 turn of the output shaft. And again, that's all going through the input shaft, going through gears to the secondary shaft and back to the output shaft, which is just actually this gear here. Can't see it, but this gear is actually part of the output shaft, and we can see, maybe, not sure if we can see it in the light that I'm working in, but the counter shaft is turning as well. So third gear, we're down to say 2 rotations of the input shaft to 1 of the output shaft, so the output shaft is turning faster again in relation to the input shaft. Then in fourth gear, the input shaft is locked to the output shaft, and I think actually what they do is push this gear over against this gear, which is again part of the output shaft. So this gear is locked to the input shaft. Then we push this gear against the output shaft. So then the input shaft is locked to the output shaft, which gives us a ratio of 1 turn input shaft to 1 turn output shaft, which is fourth gear. Now the term overdrive that we've heard in cars happens when the output shaft turns faster than the input shaft. So in our fourth gear, these are locked 1 to 1, so it's a 1 to 1 ratio. if we went through another set of gears so that the input shaft turned once and the output shaft turned, say, 1 1/4 turns, that would be overdrive. But that's not what we have in this case. Anyway, everything turns. I don't have a gear shift to try selecting the gears. So what I'm going to do, I'm going to stop the camera and see if I'm going to have to consult the manual, actually, because I only had 1 or 2 of these transmissions apart. Consult the manual and see exactly what I have to do to get this cover off. I think I can simply pull it off. If I take the remainder of the nuts off, some of the nuts are already off. Somebody's had this partially off. I like to remove that because there's the roller bearings that we saw in the clutch. There's 2 sets of those here on the shift shaft. There are springs on the gear shift that we want to check because I've seen them broken. We want to make sure the pawls on the shifter are in good condition and the ends aren't broken off of them. That would affect shifting. I want to make sure any bearings that are in here, there's some bearings in here, some bushings in here. So we want to take this apart and check it over. It doesn't look like anything's missing, but anyway, I'll pop that cover off and come back. Okay, so actually I didn't go consult the manual, I just gave the cover a gentle push and off it came. So there is the cover off of the transmission, the left cover. Pardon me, I'm working backwards here. That's the right hand cover. So what we see in here, this is the gear shift assembly, this is the sector, and underneath it, if we get the whole thing out here, take the whole gear shift out, actually take that lever out. Okay, so while we're here, we can see, perhaps, depending on the light, there are 2 sets of rollers supposed to be in there with a washer. This cover's been off before, so those bearings are off and the washer is not there. And actually I seem to recall seeing those in the bin of parts with the rest of this engine. So we do have all those parts. You just have to be very careful when you take the cover off that those bearings don't all go missing. So normally when this is put back together, the bearings will be set there in there with grease and the washer will be held on with grease, so everything will be held as it goes back together. Now, interesting enough, we can see there's a bronze bushing for the gear shift. There's a bronze bushing for 2 of the shafts here. Now this is the side of the transmission that isn't getting a lot of force. All the force, of course, would be on this end. I believe there's a roller bearing in there. Anyway, this is very dirty. It's going to be cleaned up, and we'll set the shafts in, make sure there's not a lot of play in those bushings. And here we see the clutch rod is still in place, or the clutch lever, pardon me, is still in place. Actually, as I took this cover off, I noticed one of the push rod pieces was coming out here, and here's another piece of the push rod. So there are 3 push rod pieces. This one's larger diameter than the other 2, so I'll have to remember that goes on the cover side. I'll put it in the bag with its brothers. And here is the shifter assembly. So the way this works, if I can kind of demonstrate it, is there are teeth on this part here. There's these teeth that engage with the gear on the shaft for the shifter. Excuse me. But this is the part the shift lever's on, and it moves independently of this. And this spring, if I take it out of the way, this is the horseshoe spring that sometimes gets broken. I'm just going to take that off of there. See, it's got a fair bit of tension on it. And I'm just going to see if this will come apart. No. There's a part of a snap ring. There's a snap ring with one ear broken off of it that I'll have to take off. But anyway, there's two pawls, or dogs as they're sometimes called. We can sort of see one there, and there's teeth on the back of this. So this has like a gear on it, and there are two pawls there, or dogs, that engage with it. And as that's moved, that it's set up so that this moves and then it returns. So it ratchets, it moves this ahead and back one notch at a time. Anyway, I'll have to dig at that and get that snap ring off. That'll need a new snap ring. Pardon me. But everything here is going to have to be cleaned up, checked. Just put that spring back on. So it's all in place, and there's a groove in there this pin sits in, and the spring locates on a couple of bosses there, so that all wiggles back together. So that's more or less set in place. So now we have the rest of the transmission. So we can see here, this is, hopefully we can see here, this is the input-output shaft. This is the counter shaft. This is the shifter. So this shifter has two forks on it. We can see one here, the other one's partially hidden by the case. So what we're going to do is see what comes out here. So the shift fork assembly is coming out with actually the input shaft and the counter shaft. And there we have another surprise. We have some roller bearings and a collar that are on the input-output shaft. So in this bearing, in this gear here, you may not be able to see it, but there are a series of roller bearings. And the manual that I normally use for this transmission doesn't point out where those rollers are or how many there are. So before I lose track of them, get out a handy zippy bag here to we can get them all out here, out and captured. Two more wanting to stay in. The first one of these I took apart. I had played with small engines for a while, and sometimes you try to take something apart and you don't know how it comes apart, so you get it apart, but things get broken in the process, and you don't know if you can get parts, where you can get parts, so the engine may not go back together. So the first one of these I took apart, I got a manual for, and it certainly makes life a lot easier when you know of little surprises like that. Actually, I have to admit I forgot about those, but anyway, I got away with it. 2, 4, 6, 8, 10, 12, 14 bearings. And I'll put the collar there too. So there's the collar and the bearings that were on the input shaft. Of course, they were on the input shaft because they were in, the bearings are actually in the bearing, in the end of the output shaft. Now that, it doesn't feel rough. To get that output shaft off, we'd have to take this screw off. It's hard to see because it's all dirty and I'm not working in a very good light here. This screw prevents this nut from turning. So if you want to replace the output sprocket on this engine, if it was worn, and this one's not, again, not too bad, you'd have to take you'd have to come almost as far apart as we are here. We'd have to have access to this sprocket, which means separating the transmission from the engine. You wouldn't have to take the internal parts out of it. Anyway, that lock screw holds this nut from turning, so lock screw out, nut off, sprocket comes off. And once the sprocket's off, if we have it this far apart, then we can take the output shaft out, and if we want, we can change that bearing. We might change that. There's a little bit of noise there, but anyway, if it's an easy to obtain bearing, we may replace it while we're here. And this is all old oil that's going to have to be cleaned out. Everything's got to be clean so it can be inspected and put back together. We'll set that case there. So here again, almost off out of the camera, is the input-output shaft with 3 gears on it. Now the 4th gear is part of the output shaft. So we can take that off of there. We can see that this gear slides, this gear slides, this one is part of the shaft. So we'll want to clean that up, make sure all those teeth are in good shape. That rotates on that shaft, so there may be a bushing in it. Anyway, it doesn't feel really loose. So we'll clean that up, inspect it, make sure the splines here aren't worn. They look okay, but they're pretty dirty. And here's the counter shaft. The counter shaft has 3 gears on it that move, and one that's part of the shaft. So again, we'll do this all one thing at a time so we don't lose track of where everything goes. And we'll take this apart, clean it up, make sure everything's in good shape. It's dirty, there's a little bit of rust colored stuff in here. Make sure the teeth aren't all pitted or rounded off. But one thing we have to remember when we're working on this is, if this engine was in a motorcycle and you used it, you know, it's a 200cc engine, you're not going to drive hundreds of miles at a time on it, but you might drive it around town or whatever, but you're going to be driving it at fairly high speeds compared to what the Penguin's being used at for an extended period of time, again, compared to what the Penguin's used at. So we can be a little more lenient when we're working on this. We're not going down the highway at 50 miles an hour. We're just puttering around the yard or in a parade or whatever we're doing with this. But we can let things slip that are a little maybe more worn than you'd want on a motorcycle. But anyway, this is the shifter fork assembly. It's a little hard to maneuver here because it's so greasy, but as we rotate the shaft, this fork moves endwise. So these forks move. When you turn it part way, one of these may move, and then it may move back, and then the other one moves, or they may both move at the same time. Anyway, these have to be, this is the surface they work with against the gears. So we'll check those out. Check this gear, which works with the sector here on the shifter, and make sure everything's in good shape. But anyway, I'm going to stop at that point. Everything needs to be cleaned here. I don't think there are a lot of parts required here. Maybe an output bearing and possibly a seal, but the transmission appears to be in pretty good condition, other than it's, well, now it's cleaner than it was, but anyway, a cleanup, further inspection, and reassembly with possibly a new bearing. Anyway, that's as far apart as we're going to take this engine today. We will be back hopefully with some clean parts and maybe do some installation of new parts not too far in the future.